Hi guys, welcome to my channel. I'm Naval Yemul. In this video, we are going to see what are the Sparks toolset. So if you're looking at the Spark core, so the map reduce, or if you compare with the Hadoop, so in Hadoop we had a map reduce. So that map reduce got replaced. You can say that map reduced got replaced with your Spark. So now if you look at what are the tool sets of Spark, so what is there inside the Spark? So if you compare with the Hadoop, so this MapReduce is replaced with Spark. Now inside the core of Spark, there are actually Spark session, Spark context, and you have an RDD. So if you talk about low level core APIs of Spark, low level core APIs of Spark, that stands out like Spark session, Spark context, and your RDD. So what is RDD? We will discuss in detail. We are discussing all this in detail. Then when you are talking about the higher level than this low level, so we have data sets, data frames, and your SQL language. So first we need to understand what is exactly your low level core API. So you can, I call this as a core API. And on top of this core API, you have these higher level APIs. For example, data sets, data frames, and SQL. And you can use Spark for various purposes. Like you can use Spark for streaming, you can use Spark for graph computing, you can use Spark for any other libraries and packages. And if you look at the high level APIs, like you can use any programming languages with Spark. You can use Java, you can use Python, Scala, and R. So this thing is very clear because Spark supports all high level APIs like this programming language, but we are restricted to using a Python in this course. And when it comes to packages, so we have discussed about what do you mean by streaming. If you have a non-relational database like NoSQL, and if your data is in like no relation between the tables, then we go for graph computing. If we have different libraries and packages, this also supports your Spark. Now, first, let us discuss on these two. Before going to datasets and data frames, we are going to discuss about the detail about this low level APIs. For example, first let us discuss on what do you mean by RDD and then we'll go proceed further. So before going to RDD also, let us see on what are the Spark components, what I personally feel that these are important. So in our like coming sessions, we are going to see most of the time what is data frame, and then we are going to see what are Spark SQL, and we are going to see the Spark streaming also. If we are going into machine learning, then we would have or we would start with machine learning libraries, that is mlib, and graphics also. But in this course, we are going to see what is data frame, Spark SQL, and your Spark streaming also. Okay. So this is your Spark core. So inside the Spark core, we have all this. So I have picked only few of them. Like I have picked data frame, your Spark SQL, and your streaming library. From this, you can see 1, 2, 3, and I have kept it here. So we will be continuing most of the time taking data frame. Now, what is data frame? Before we understand what is data frame, you need to know what is data RDD, that is resilient distributed dataset. Okay, so let us see about RDD. So before we go to RDD, I would like to show you like what do you mean by ETL process. So you look at any big data project, or if you look at any data engineering one, a broad classification of their work would do a ETL or to build a pipeline. Okay, pipeline. So the pipeline can be, suppose just imagine your data sits somewhere in the source. This source can be anything. It can be your storage account, or it can be your any cloud storage anywhere, or it can be your data coming from the IoT, data coming from the Salesforce, and so on. So there can be various storage systems, or you can call this as my source. So data is or data sits in the stores source. So this can be in the various formats. Now we are going to extract these all data. We are going to extract these data and we start transforming it, because this data is in your raw format, raw data. We call this as a raw data. We extract it and we start transforming it. Now, what do you mean by transform? So we do transformation. We convert this raw data to a meaningful data. Okay, to a meaningful data. I'll tell you what exactly how your raw data looks like. Let us consider your raw data looks, or it's in a JSON format, and we are converting that in a meaningful data. Now we are converting that to a table. Okay, just imagine now table as a rows and column. So we are doing that in a tool PySpark. I majorly we are doing in Spark, but we are using a language called Python, so we call it as a PySpark. So we are going to transform that. So to run this PySpark language, we need one of the framework, one of the tool to use this PySpark. So we are using a Databricks. Okay. So I'll explain more about Databricks. So in this, like to run PySpark, we use Databricks, or Spark sits on top of this Databricks. Sorry, Databricks sits on top of this Spark. So we are going to do a lot of transformation. And once your data is converted to a table, we start loading that into the destination. Now your destination can be again a storage account, or it can be your SQL server, or it can be your any database, or it can be your directly connected to a BI team, or BI stands for business intelligence. So this is exactly what your ETL looks like, or a pipeline looks like. So if you look at a pipeline, so here we do extracting data from different sources and do transformation, and then we load wherever you want. So this is basically a work of data engineering or a big data people. So now when you focus on this transform, so if I focus on this transform, so for transforming in PySpark, now we need a data structure, like something, a data structure. So to understand in a layman language, so we need a data structure. So in Spark, there are basic three data structures. So first is RDD, second is your data frame, and third is your dataset. So to do the transformation, we need to write a code. So we will write a code by using a data structures. These data structures are in Spark. These three are the types of data structures. One of the core or one of the oldest data structure is your RDD. RDD. Then we have data frame. Then we have dataset. So to do transformation, we need a data structure. That data structures are nothing but RDDs, data frames, and datasets. Now you should know what you mean by RDD. So I'm talking so much about RDD. What is RDD? So let me go. Now if you look at the history, so when Spark components started, so they have started with Spark 1, then they have released Spark 2. Now we will be using Spark 3, and the latest version when I'm taking this session is Spark 3.3. Okay, so RDD is called Distributed Dataset. So if you look at history, it was started when Spark Core or Spark 1.0 started in 2011. So there were some like limitations on this RDD. So on top of this RDD, they have built data frame and data set. You can see in 2011, RDD was built. On top of this RDD, your data frame was built, and from RDD, a data set was built in 2015. Now, if you know RDD, so these two data frames and data sets are derived from this RDD only. So these are derived from RDD. You can see the arrow. So this data frame was derived from the RDD, and your data sets is also derived from the RDD. So first and foremost thing is we need to know what do you mean by RDD. Once you understand like how RDD works, then we can proceed further to data frames and then proceed further to data sets. So let us look in detail what do you mean by RDD. So I'll just written a definition of RDD. So RDD stands for resilient distributed data set. So it might sound confusing because at the beginning, but it is simple. So Spark RDD is resilient, it is partitioned, it is distributed, and it is immutable collection of data. So let me decode one by one. So first is collection of data. So when you look at the collection of data, so your Spark holds all your data in a Scala collection. So now if you ask me like Spark, in which language this Spark is written? Spark is written in Scala. So all your data, whatever data you are bringing into Spark, that holds or that appears to be in a Scala collection, because the language of Spark itself is a Scala collection. I hope this collection of data is clear to you now. Okay, so we are decoding one by one. Now, what do you mean by resilient? So resilient means RDDs are fault tolerant. So fault tolerant. So it is a process that enables an operating system to respond to a failure in hardware or software. Just imagine there is some mishap happen. There's something happened on the software side or on the hardware side. So because of this software has a fault tolerant, you can easily retrieve the data whatever you have lost. Not whatever you lost actually. So whatever is in the process, you can easily fetch. For example, I'm working on a data set which is having 10 plus million rows. Okay, huge data. Just imagine. Now I'm doing transformation and I have transformed few rows. Few rows means I have transformed 1 million rows. Now there is something mishap happened. So I don't know that there is a failure in software or there is a failure in hardware. I don't know exactly. But this RDDs support do not support fault tolerant. Let us assume that we do not support fault tolerant. So whatever transformation we have done, this 1 million is all waste now, because because we have do not have a fault tolerant, we cannot retrieve like whatever transformation we have done before. Now let us imagine that your RDDs are fault tolerant. Yeah, it is fault tolerant. So it can say that, hey, you have done with 1 million transformation, you can proceed further after 1 million if you have a mishap or if you have any problem on the software side or hardware side also. Any interpret or interruption on any side, that will take care. So RDDs are fault tolerant. If you have any problem, any components fail, so we are talking about a clusters. So we have a driver node, we have a worker node, inside that we have cores. So just imagine anything can happen. So if a core fails and if your data sits into that, not to worry, RDDs are fault tolerant. You will get your data back, or you do not miss any of your transformation. This is what the fault tolerant is. So next is, so we are done with the collection of data. It is all a Scala collection and we have seen what do you mean by resilient. So there are fault tolerant. Then when you talk about the next point, that is partition. So if you remember, on the driver node, I have shown you the Spark architecture. In the driver node, now if you have a huge amount of data, this driver program, I told you, like this driver program in turns partitions the data and starts distributing the data to different cores or different executors. But in in detail, if you go in depth with this driver program, actually inside this driver program there is an RDD. So RDD is your resilient distributed data. So the data which is partitioned, so who will partition this data? So this RDD is responsible for partitioning the data. You can see Spark breaks down this RDD into smaller chunks. So it will break down into smaller chunks of data, and these pieces of data are called your partition. So it will partition this, and these small chunks of data are called partition. So who will partition the data? Your RDD will partition the data. And once your data got partitioned, it starts distributing. So these Spark distributes these partitions across the cluster. I mean across different worker nodes. So inside the cluster we have different worker nodes. Then your partition data gets distributed. And immutable. So immutable is nothing but once you have defined that, you cannot change. Now like at the very first time it looks very weird, like, oh, if I create something, like if I create a RDD and I cannot change them. Yes, you cannot change this RDD because this is an immutable. So yeah, so these are the points, or you can call these are the definitions of your RDD. So RDDs are nothing but resilient. Resilient means fault tolerant. It will partition and distribute. Partition means it will partition into smaller chunks and distribute, and these are immutable. So this is how your RDD looks like. So if you go back and see, like these RDDs, on top of these RDDs, our data frames are built. So we have seen what do you mean by RDDs. RDDs are resilient distributed data sets. Those are partitioned. It will partition the data. It will distribute the data. Those are immutable, and so on. But on top of this RDD, they have built a data frame. So if I want to define data frame, so it has all the capabilities of data RDDs. For example, data frame are immutable, data frame partition the data frame distributes the data frame holds the data in the Scala collection, and so on. But it has some additional features on top of the RDD. So this RDD is the oldest, and it is one of the, sorry, it is one of the core. So it is oldest and it is a core component of Spark. So as it was the old, there are some limitations and some disadvantages on RDD. So because of that, they have built a data frame. So data frame obviously has all these points. Additionally, data frame is like, when you talk about data frame, it looks like a structured API. Now if you say what do, like how does a data frame looks, data frame looks simply like a table with data which has rows and columns. So if you look at a table which has some columns and some rows, then you can call this as a data frame. Now you might be wondering, like, hey, I'm talking about big data, I'm talking about big data formats like JSON, I'm talking about XML, I'm talking about HTML, all these formats. But how to get all that format in a table? If I have a table, then I would not come to big data only. So I can do anything if I have a table. No, you are going to convert this all raw data into a data frame. Once you convert that, this data frame looks like a table. It is looks similar to your database table. And but now if you ask me, what is the difference between a table and data frame, then can I call a table a data frame? No. So there is a difference here. When you talk about data, a table or a single spreadsheet table, so that table, all your data sits into one single machine. So spreadsheets on a single machine. But when you look at your data frame, your data frame is partitioned and this has distributed. Suppose if you're having three cores, so some partition data is distributed on the first core, some partition is distributed on the second executor, some partition is distributed in the third executor. You can see the diagram here. Some data sits on the other servers, some data sits on this servers, some data sits on this servers. So your data is not only storing in single machine, but those are splitted, or you can call partition and distributed across different servers. So because of that, you can say the difference between the table and data frame. So your table and spreadsheet sits on a single machine. Your data frame's data is distributed across different worker nodes. So this is all about RDD and data frame. I hope you enjoyed the session. Keep learning, guys. If you like the content, please like the video, subscribe to my channel, and share it with your friends. Thank you for watching it again.